I was playing with Incircles a little while ago. Somebody gave me a puzzle, which actually I don't remember because I was overwhelmed by the fact that while trying to solve the puzzle, I accidentally proved Pythagoras' theorem, as you do. Those people who know me will go, of course you did. Right, so that's just something that happens. But I started to think of incircles, and if you relate incircles of triangles and you look at Heron's formula, you can end up doing all sorts of wonderful things about calculating the radiuses of incircles. And the thing to do this is, and Hugh Hunt, professor of engineering at Cambridge, was very surprised to discover that if you take our old friend, using the high-tech side of things here, our old friend, the first primitive Pythagorean triangle, and we ask about the incircle, which I still can't draw accurately despite how much I try, and look at the radius, then fairly clearly it's going to be the radius of a circle in a triangle. It's going to be got square roots and all sorts of horrible things going on. But no, it's 1. Right, now some of you know that. That's really cool. Some of you will have met this before. Some of you will calculate it quickly. And that's a really nice thing. Hugh was very surprised by this. And he said, this is the sort of thing that we should be showing school kids because it's nice, it's surprising, it's not difficult to prove. If you draw that line, that line, that line, then we get a kite there and a kite there. And if that's r, then this is 4 minus r, this is 3 minus r. And that means that this is 3 minus r, and this is 4 minus r. And that means that 3 minus r plus 4 minus r is equal to 5. So 7 minus 2r equals 5. So r equals 1. Okay? And it's not difficult to do. If you didn't follow that, don't worry. You can do it for yourself. Or you can come and ask me, and I'll torture you later with more of these details. The thing is, some of you will know that we can get a primitive Pythagorean triangle by taking any odd number, and I'm going to go to 7, and square it, which gives us, in this case, 49, halve it, round up and down, and that gives us 24 and 25. And that is a primitive Pythagorean triangle. And if you take the incircle in that one, which I still can't draw, and look at the radius, it's 3. Right, I've got a heckler in the audience, excellent. So you get 3, and this is another integer, and Hugh was surprised by this, and he said, well, can we get all positive integers like this? And is it always a positive integer? And if you do the calculation I did over here, but instead of using 3, 4, and 5, you use A, B, and C, then you end up showing that it's going to be an integer divided by 2. So at worst, it's an integer and a half. How do you get that extra thing to show that the top line of our fraction has to be an even integer? That's a nice little puzzle if you want to have a look at that. So it turns out that you can get, you only get positive integers when you take the radius of the incircle of a primitive Pythagorean triangle. And indeed, if you go up with these odd numbers, you get all positive integers as being the radius of the incircle of a primitive Pythagorean triangle. I never get tired of saying that. Primitive Pythagorean triangle. But if you take another primitive Pythagorean triangle, another of our friends, not in that sequence, if you take 8, 15, 17, so 15 squares, 225 plus 64 is 289, the radius there is also 3. So some integers turn up more than once. And we had an email discussion going on about this, and Hugh was trying to hunt this down. He was very confused because he didn't start with this sequence where you take the odd number and do it, so he couldn't see the immediate rules. But somebody else was late to the party and said, okay, so we've seen that it's all been proved. So I showed Hugh the arguments. He thinks they're really nice. So we did that, and this other chap said, okay, I'm too late to the party here, but I have worked out, he said, I conjecture how many there are for a given radius. So if I give you a radius of G4G15, how many primitive Pythagorean triangles have an incircle of radius 15? The answer is 4. How many have a radius of 45? The answer is 4. What about 162? The answer is 4. Do you want more than 4? We can get more than 4. 105, the answer is now 8. So where's this coming from? you'll notice that all the numbers I've given you so far are even. It turns out that for a given radius, r, the number of primitive Pythagorean triangles with an incircle of radius r is 2 to the power of the number of odd prime factors of r. Okay, now this is not new. This is not new. It actually, there are references. We've found references dating back around about 15 years or so. So it's not only 15 years. We haven't been able to trace it further back than that. Some of this stuff is fairly well known. But if you want to find out more, you can come and ask me. I'm around until Sunday afternoon because that's when I was expecting to talk. You can find me on social media. I am Colin the Mathmo on X, where X is Mastodon. Thank you very much.